Hello everyone, today we're gonna perform experiment number 2 for a power electronics laboratory, which is entitled Instantaneous Power, Energy, and Average Power Using PSpice. Brandon's Vlog. The objectives of this experiment are to simulate power electronic circuits to determine the voltage currents and power quantities, to utilize the functions to measure the energy and steady-state RMS current.
Now, let us begin with the experiment. The first part of the experiment, we would be using PSpice to measure and see the waveforms flowing through a resistor with a given voltage source. Now let us begin. Open the OrCAD Capture PSpice and click New Project. Choose Analog or Mixed AD, name it as Experiment 2. Then let us select its designated folder. Click OK. Now, we would create a blank project. Click OK. Now, we would create the circuit as shown from the illustration. Use V sign for the sources. Now let us edit its configurations. We would set it to have an amplitude of 10 volts and a frequency of 60 Hz. Now let us place a resistor on the circuit. The resistor should have a resistance of 5 ohms. Let us add the ground. And connect the circuit by using the wire. Now, let us create a simulation profile for the experiment. Select the time domain transient in the simulation setup. Enter a runtime of 16.67 milliseconds. Now, we would add a probe on the resistor. A probe for the current and the voltage. Now let us run the simulation. After running simulation, the PSpice window opens up. From the PSpice window, we see the green waveform and the red waveform. The green waveform is the waveform of the voltage. It is seen that it has an amplitude of 10 volts. On the other hand, we can see the red line, which represents the current flowing through the circuit. It has an amplitude of 2 amperes. Now let us add the waveform for the power flowing through the resistor. It can be seen that it only has positive and absolute values, since the waveform does not cross the zero line. Also, it is seen that the amplitude of the power is 20 watts. Now, let us try to add the average waveform of power. Click Trace, Add Trace, then under Analog and Operators and Functions, click Average. And let us add the waveform. The waveform of the average power is represented by the yellow line. Let us see the value of the average power flowing through the circuit as absorbed by the resistor. It is seen at the end of the cycle. From here, we see the average power is 10.07 watts. To recap, the blue line represents the power waveform. It has an amplitude of 20 watts. The yellow waveform represents the average waveform. From here, we could see that at the end of one cycle, the average waveform is 10.07 watts. The green waveform represents the voltage, while the red waveform represents the current. It is seen that the voltage and the current are in phase since this is a purely resistive circuit, which means there is a 0-degree phase difference between the voltage and the current. The second part of the experiment will be tackling about RMS values. Now let us try to build the circuit. The circuit would use a pulse source. Now let us edit the configurations. Now let us add the resistor. The resistor is configured to have 2 ohms. Let us add the inductor. The inductor is configured to have 10 millihenries value. Let us add the ground. Now let us connect the circuit using the wires. Now let us edit the simulation profile. Set it to 100 milliseconds. Let us run. Before starting the simulation, let us add a probe. From here, we could see the waveform of the input voltage. It is observed that the input voltage has a waveform of square waves or pulse waves with an amplitude of 20 volts. It is also observed that one cycle occurs at every 20 milliseconds. So after 20 milliseconds, another cycle occurs. Upon running the simulation, we could see the current waveform represented by the green line. The current waveform has an amplitude of 7.97 amperes. Now, let us add the waveform of the RMS current. We could see that the RMS current is represented by the red waveform. Now let us try to find the value of the RMS current. At the end of 100 milliseconds, we could see that the RMS current is 4.6303 amperes.
Conclusion. The experiment was conducted using OrCAD Capture CIS Lite for building the circuit and PSpice AD Lite for running the simulation. One can easily identify the peak current, peak voltage, or maximum power delivered to the resistive load by looking at the graphical representation of the waveforms with respect to their designation. Moreover, one can identify the average power, as seen from the experiment, by looking at the average power's Y value after one period. For the case of the experiment in part 1, one period occurs after every 16.67 milliseconds, since the frequency of the voltage source is set to be 60 Hz. The period is the reciprocal of the frequency. The second part of the experiment follows the RMS current of the circuit with an inductive load and a resistive load. Through the graphical representation of the waveform, it is observed that the voltage source waveform is a pulse wave occurring with a period of 20 milliseconds and an amplitude of 20 volts. On the other hand, the current flowing through the resistor is also shown in the simulation process. The RMS currents waveform was also formed, and the value is represented at the end of one cycle of the current waveform. The current waveform occurred every 20 milliseconds, which is why at 100 milliseconds, there are 5 cycles of the waveform seen. Recommendations: it is wise to check and make sure that the ground is present before simulating the circuit. It is also advisable to edit the simulation profile for the user to determine the desired stop time for the output waveform. Knowing the basics of ORCAD and PSpice is advisable before proceeding with the experiment, so make sure to practice and know the basic commands and functions used in the simulation software used for the experiment.